All right, guys, here we are in part 2 of the Introduction to Water video. Go ahead and make sure you have your salt and H2O science packet out, and we're going to be doing pages 4 and 5. Let's jump on in. All right, number 1 says to circle the solution. What is a solution? Well, first of all, let's preview what we've got here. I've got a fake little picture of gravel and water, milk and water, and salt and water. And this reminds me of that experiment we did on Monday where I had a couple different cups of water and I tried stirring different things to see if there was a reaction in it, right? Let's review what a solution is. A solution means that there is a mixture of two or more things. So in this case, it's always going to be water and then something else. On the left, we have water and sugar. On the right, we have water and sand. But they are what's called homogeneous. Homogeneous. And that's a big science word. But what that means is that this mixture, the extra thing, the either sugar or sand, gets spread out evenly all the way through the water. And there's no chemical reaction. There's no like slime that's made or anything. So with sugar, yes, sugar is a solution. Because when I add sugar to water and stir, the little tiny sugar molecules get popped apart, just like a magnet the water's magnet pulls the sugar molecules apart and spreads them evenly all throughout this water like little sprinkles, so small that you can't see them anymore, right? But with sand, if I add sand to the bottom of this glass and stir, might be that there'll be a little whirlpool that formed, but eventually the sand would settle back at the bottom. It wouldn't spread out throughout the water, and the water's magnet would not be able to pull sand apart. Sand stays together. So sugar and water is a solution because it splits the sugar apart. All right, looking back here, which one of these do you think water could split apart to make a solution? Do you think it's gravel? Could water split rocks in part? Milk? Or salt? The answer is salt. Water is great at splitting salt molecules apart. I know it's a solution because the solid disappears into the liquid. It doesn't actually disappear, but it looks like it because those salt molecules are split into such tiny pieces that you can see through them, and it's almost like they aren't there. And the mixture is, and here we're going to write this giant new science word, homogeneous. 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 Go ahead and say that in your head. Homogeneous. And if you want a challenge, write it in bubble letters. Okay, number 2. Salt crystals always appear as, I want you to predict and then I'm going to show you, either a sphere, rounded, or a square or cube shape. Think about what we looked at on Tuesday to look at salt. The answer is cube or square shape. Look at that. Those are like beautiful. This hasn't been chiseled or worked on in any way. That's just what salt looks like naturally. So square. Number 3, when a liquid changes to a gas, it is called, so this is what would I call the state change from that, and that is evaporation. 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 All right, number 4. How could you separate a cup full of ocean water into drinkable fresh water and then sea salt? So this one, if you think back to what we learned about how we actually harvest sea salt, I think you'll get it. I'll give you just a second. Okay. The answer is evaporation. And hopefully if you do this right, the water would evaporate, turn into a gas, and rise up, leaving the sea salt behind on the ground. And people who have been like stranded at sea and things like this sometimes try things like this, or people who live in desert landscapes will try to get water vapor to collect on something to help for fresh drinking water and things like that. So it's good to know in case you ever need it. And then our bonus, we're going to find the meaning of dissolved, and more specifically the Latin roots for it, dis and solve. So let's look at dis. Let's look at this. Dis. Dis means apart or not. So they have this huge word tree up here for all different kinds of things that use this. But let's say displeased means you are not pleased, right? Disparate, you probably don't know that word, but means apart. And then for here, remember, our big question is dissolved. What does that mean? So right here under dis, let's put apart. I remember that water is like a magnet. Apart. And then solve, S-O-L-V, means to loosen. Loosen. Okay. Coming back here. So really dissolved means to loosen apart something. And that makes perfect sense because think about what happens when I dissolve salt in water. Those magnet water molecules pop them apart. They loosen them apart. All right. And then we'll finish with number 5. I'll keep it pretty quick. Y'all have been great and patient with me. I know these videos are longer this week. I just wanted to give you kind of a visual of what's going on when a solution happens. And remember, a solution is when we add something to water and those molecules get pulled apart by water's magnet and then go evenly all throughout that water. And my example is going to be salt. So I got my little table salt shaker. And we know that salt on the molecular level, when I zoom way in, has a big fat chlorine molecule, atom, and sodium atom, right? That little bubble, Na is sodium. Weirdly, I know it should be an S, just, science. And then these two cluster up together to make little cubes that float around. That's what salt looks like on the molecular level. And then we remember that water looks like this little Mickey Mouse. It has one big oxygen and 2 tiny hydrogens. And then do you notice how I have a plus and a minus? A plus and a minus? Well, think of those like this, again, the separate ends of magnets. And they're naturally going to want to cling to each other. Opposites attract. So a positive would want to stick to a negative, and a positive would want to stick to a negative. So when I dump the salt into the water, they instantly start popping and separating inside of each other until it looks something more like this. See how they're starting to cling to each other in different shapes? And notice how we don't have that beautiful cube shape of salt anymore, which is why it seems like the salt has turned invisible, right? All right, guys, that was science for today. I hope you've enjoyed this entire week's introduction to water. Next week, we're going to kick it up a notch. There's going to be plenty of hands-on science experiments, and we're going to even do a little bit of science baking. Looking forward to it, guys. Bye.